future value of an annuity. With two key terms we have to understand clearly. What is an annuity and what does future value refer to? Annuity means equal payments are made at regular intervals with interest compounding at the end of each interval. The future value means we look at the total of all these contributions plus the total of all the compound interest earned at the end of the period. Example 1. John is saving for a special holiday and invests $1,000 at the end of each year for 4 years at 8% per annum. Find the total amount at the end of the 4 years. Once again, we check that the interest rate is per annum and it's a yearly amount that he invests. So the same time unit is used. At the end of year 1, John invests the first $1,000, so that's the amount in the account at that stage. At the end of year 2, John will have the $1,000 from year 1 with interest earned on that $1,000, as well as the second $1,000 he invests, which will give a total of $2,080. At the end of year 3, John will have whatever he had at the end of year 2, with interest earned in the third year, as well as the third $1,000 he invests. And that will give $3,246.40. At the end of year 4, John will now have whatever the total at the end of year 3 was, with interest earned in the fourth year, as well as the fourth $1,000. So the total in the account will be $4,506.11. When you use this method, always show clearly with which year you are working now and show all working very clearly. You can now pause the video at this stage and do question 1 in your exercise books using the method we have just looked at. Example 2. We're going to use the same information in example 1, calculating the future value of the same annuity, but this time showing the working in a table. At the end of year 1, he invests $1,000. This $1,000 has 3 years left to earn interest. Therefore, at the end of the 4-year period, this $1,000 would have grown to 1,000 times 8% for 3 years compound interest. That will be $1,259.71. At the end of the second year, the $1,000 invested then will have 2 years left to earn interest. So that will be worth 1,000 times 1.08 compounded for 2 years, which will have grown to $1,166.40. At the end of year 3, that $1,000 will have 1 year left to earn interest at 8%, and that would have grown to $1,000.80 at the end of the 4th year. The $1,000 invested at the end of the 4th year does not have any time left to earn interest, so that just stays at $1,000. Adding up these 4 amounts gives us the total in the account of $4,506.11. Question 2. You now use the table method we've just looked at to calculate the final value of the annuity in which Josh deposits $2,300 at the end of every year for 4 years at an interest rate of 9% per annum. Once again, you can now pause the video, first do question 2 in your exercise book, and then continue watching the rest of the video. We have seen that both these two first methods are quite tedious, with a lot of writing out and a lot of working out. Luckily, we find interest factor tables where many of these steps have already been done for us. This is just a very small extract of such a table that shows the interest factor for investing $1 at 7% for 4 years will be 4.4399. So if you invest $1,000 at 8% for 3 years, the final future value for that annuity would be 1,000, because that's the amount you invest every year, times 3.2464. If you invest $500 at 7% for 2 years, the future value of that annuity would be 500 times 2.07. The formula used to calculate these interest factors is 1 plus the interest rate as a decimal to the power of how many time periods minus 1, and that answer divided by the interest rate as a decimal. Let's look at example 3a. You're going to use the table of interest factors to calculate the future value of an annuity in which $500 is contributed every year for 3 years at 7.5% per annum. The formula we use is FV equals M times I. FV stands for future value. That's the value of the annuity at the end of the time period. M is the contribution made each time period. And I is the interest factor you find from the table that's, we've just looked at a small extract in the video, and there's a more expanded one in your textbook. So if we look at this example, the amount contributed every time period is $500, and the interest factor for 3 years and 7.5% is 3.2306. This interest factor comes from the table that will be given to you. Multiply that and it gives you a value of $1,615.30. If I now want to know what's the amount of interest that I've earned on this investment, I invested $500 3 times. So I can take the future value, $1,615.30, minus my investment of 3 times 500. So the interest earned on this investment is $115.30. A next example. Determine the interest rate and the number of time periods you have to use finding the factor in the interest factor table for the following annuity. $100 invested every month for 3 years at 12% per annum. We now see that the interest rate is per year, but the investment occurs every month. So we first have to get those two pieces of information in the same time unit. We have $100 per month. In 3 years, we have 36 months. And if the interest rate is 12% per year, 12 divided by 12 is 1% per month. So I will now go to an interest factor table and find the interest factor for 36-month period at 1% per month. That will give me 100, because that's the investment per month, times 43.0769, and that you can find on the factor in your textbook. Once again, you can now pause the video and do question 3 and question 4 to finish off your homework for this section.